joining the April 26, 2018 VOLTHA TST call. We are recording the session to post it later to the VOLTHA playlist on YouTube, so please keep that in mind during presentations and during discussion. And on the agenda today, we have two topics. First is the deeper dive on the G.fast proposal from AdTran. And then following that, we will have a readout on yesterday's technology profiles discussion that took place. And I'm not sure if that's going to be presented by Radisys or Sean, is that going to be presented by you?
Me? No.
I don't know. Okay.
Oh.
All right. Then with that, I think we will go ahead and I will give presentation rights to Andy so we can start the G.fast discussion.
And I'll start with apologizing. If I go on mute, I'm fighting a cold, so I may go into a coughing spell. I'm not trying to be rude.
All right, Andy, you should have presentation rights now.
All right. Are you able to see my screen?
Yes. Great. Thank you.
Okay. So Philip Herring from AdTran had joined the last lockdown session and had presented some slides. These are the slides that Philip had presented. It sounded as though there were some open questions still, some a little deeper investigation to some specifics. So rather than going through a lengthy presentation of more details, I wanted to make sure we address specific questions or concerns and talk a little bit about the philosophy of our proposal. And there was one slide that he did not get to that we could share as well that kind of shows that. So if there's any specific question that we should start with, I'd like to hear that. Okay. So to revisit it, to dig a little deeper, possibly, our philosophy, our proposal is rooted in the fact that we want to make minimal changes, if any, to VOLTHA, keeping the VOLTHA core as its pattern today, keeping everything aligned as today. And so a DPU and an OLT are both aggregation devices, and we want to model them as such, and we want to allow VOLTHA to represent them as open flow switches to an open flow world. And so a DPU, whether it be point-to-point fed Ethernet or whether or not be PON-fed DPUs, both of them are open flow switches in our proposal. This allows series and sequencing of both the OLT and the DPU, and that's what Philip went through from these slides, showing that an OLT and an ONU, as you know it today in VOLTHA, come on board, go through the sequences of discovery, go through the pre-provisioning, as well as the port up, etc. And then that ONU is now ready and listening to various authentication, etc. from a subscriber. And our proposal is that the DPU is treated no different than a subscriber, with the exception that the applications and the ecosystem is aware that there will be additional devices in the network, and so it would identify this as a DPU device and authenticate it accordingly via EPOL, for example, as well as bring it into the network and allow DHCP call home kind of behaviors are outside of VOLTHA, as we talked a few sessions ago, and that it would be able to be provisioned in and realized as an open flow switch, just as an OLT is. And then just as an OLT begins with a very simple flow construct, the DPU would be as well, allowing for discovery and connectivity of CPEs or G.fast RGs, but still keeping the G.fast termination point as the link up in order to show the open flow world that a port up has occurred, and then begin to take action to prescribe the exact same flow sequences that you would from a subscriber perspective, creating a cascading of open flow switches, allowing you to manage this either from an intention perspective across all of them, but in our current proposal, in order to keep things as aligned to the VOLTHA community as possible, we see it just as very similar, if not identical, to the flows that would go into an OLT ONU construct, would be pushed down to a DPU CPE construct. This would allow for the applications as we know them to remain unchanged for the most part, and just be surgically adjusted in order to accommodate this behavior. And then as the OpenFlow discovery happens, as packets are processed from the RG, the same applications that you're aware of today would add the additional flows in order to allow the network traffic that is based upon that service to actually be applied. One aspect, a simple markup diagram that we had done. As you know it today, this is the Edge Core Broadcom OLT ONU adapter and how those device adapters exist inside of VOLTHA. These are from the VOLTHA community's webpage. A simple augmentation in order to show how the same behavior, just as a flow rule is dissected across OLTs, ONUs, our proposal is that it would be very similar conceptually and logically across the DPU CPE. However, how the adapters, the device adapters, are actually used in order to negotiate that is dependent upon whether this is a CPE that is an extension of the DPU or whether or not it has more intelligence to it. So the example we show here is that we logically represent them as two individual adapters, but the CPE adapter actually will communicate to the DPU adapter similar to an ONU to OLT, but rather than pushing down over OMCI to the Broadcom ONU on the left-hand diagram, the DPU would actually take action to logically represent the and instantiate the network functions that we'd be requesting of a CPE. There are various communications across the DPU to the CPE that would help realize those. We don't want VOLTHA to have to be aware of those. We want to abstract that away.
So the CPE adapter, right, so it only address the physical layer of the CPE. What I'm saying is the G.fast portion, the link between the DPU and the CPE, right? So it's actually very interesting in some ways. You know, I always thought that. I mean, I'm just making a comment here, right? So I always thought because a lot of time the CPE and the RG are integrated in some way. So and often on the ONU side, the ONU and RG are separate, right? So yeah, so it is very interesting. The CPE actually require adapter in the DPU case because that's where your customer prem and that's the endpoint.
At this point, Sean, we have not integrated the CPE into any RGs at this point. It is a standalone box. Like
for the DPU, for the G.fast. Oh,
yes.
Okay.
And it actually does actually have a separate software load.
And so managing upgrade software, as Mike says, there's also aspects of link up, link down, or speeds, or counters, or there's certain aspects dependent upon which CPU you use and how your DPU communicates with it. That ONU adapter, that CPE adapter on the right-hand picture may be very simple, or it may be fairly complex. But the key is to allow the OpenFlow community to see that it is abstracted away from whether this is an OLT ONU construct or a DPU CPE construct. It's an OpenFlow switch with a port, period. And you can live in the OpenFlow world and be 100% abstracted away from the physical aspects of how these work.
Hey, Mike, thanks for the reminder of that, because I have to say I have not been following the G.fast too well. But great, thanks.
Hey, Andy, I have one question. Hello.
Amit, yeah?
We can hear you.
So, Yeah, so in this case, we have two logical devices at ONOS. So when a flow, excuse me, when a flow needs to be provisioned for a particular subscriber, the flow rules need to be pushed to both the logical devices, right?
Are you referring to the OLT ONU logical device and the DPU CPE logical device? Just as when an OLT adapter abstracts this OLT ONU construct, that's a single logical device inside of ONOS.
Correct.
The DPU CPE is a single logical device inside of ONOS. A DPU is just an open flow switch, and those CPEs are the ports associated with that switch.
Yeah, so my question was that for a subscriber, when we provision the flow rules, those flow rules need to go both to the OLT logical device as well as the DPU logical device, right?
It depends. That comes into a traffic engineering architecture perspective. In this top row, the flow rules you would push to just an OLT ONU construct. Those same flow rules that talk about the uni handoff and the handoff, etc., would be still applied to this right-hand side regardless. But this OLT, if it is aggregating DPUs, may have aggregation flows as opposed to per subscriber flows. But that's a network architecture conversation as to it doesn't prohibit you either way. It depends upon how you desire to do it. Here in our proposal, how this works, the subscriber flows that are pushed down to the OLT ONU construct are handled via the exact same cord applications that you're aware of today, with the exception of when the subscriber authenticates, the tag and the membership of what it joins, right? From a management perspective, there would be a management flow that would be configured in there so that you could manage the DPUs. But then there would also be a subscriber flow that the DPU would place its traffic on. And so you're not provisioning to two places, you're letting both places individually provision what they need to based upon the flow rules.
When we at AT&T set this up today, we and obviously this is not how it's done in Volta today, but the way we aggregate the DPU is configured, the subscriber flow information is known at the DPU and is untouched through the OLT. When you add a DPU onto an OLT, that DPU kind of becomes an aggregate subscriber. So what we do today is, in terms of our VLAN tagging, is we have a single tag that's applied at the DPU, and then when the traffic comes up on that DPU port into the OLT, it's all all of those single tags go into a single outer tag. So you end up being double tagged out of the top of the OLT, but the OLT doesn't know all the individual subscriber tags. The OLT doesn't manage or traffic shape or have any subscriber policies. The OLT has a policy and a PON bandwidth allocation, for lack of a better term, that is set for an aggregate of the DPU. So we don't currently mix in AT&T a type of DPU deployment with an SFU deployment. We don't do that currently today, which is not to say that that wouldn't be something we would consider doing in the future. But right now, when the DPU would come on, when the DPU would get instantiated, when the port up would happen on the ONT that would go up to the OLT, and when you get your port that's on the OLT, that would be not a subscriber flow, but would be, there would be some type of, flow that could be set up that would provide the DPU an aggregate bandwidth as if the DPU was the port, not as if the individual subscribers would. That's the way we manage it today, is that the DPU has a subscriber knowledge. The OLT is a pass-through pipe.
And this design doesn't prohibit, Amit, what you speak of doing an end-to-end flow and informing on us to place an intent across two open flow switches. Our proposal right now is more aligned with our experience, such as AT&T, where providers wish to keep the aggregate network individually managed from the subscriber, the edge, and that has to do with operational behaviors. And so the proposal allows either, but incrementally aligning with that, what I refer to as carrier of carriers, or segmented, is what this proposal would most likely be initially used as.
Okay, thanks.
I think it will be interesting to, I guess, even though I work on this for a while, the difference between flow and layer 2 VLAN still a little bit confused to me. So maybe in a follow-up discussion, maybe we can have an example how the VLAN tagging works, on the pump
sequence, as well as what the VLANs on the actual physical showing, such as a quote-unquote legacy or a quote-unquote historical device would render from a VLAN management perspective.
Right.
Yeah, we could show a more detailed version of that. Absolutely.
Right, and then how exactly translate into a flow, right? So yeah, I think the mapping of that, and then not just the one legacy cases. Maybe if there's other mechanism will be better suited for open flow switch. Maybe let's give a thought about that, and then maybe have a revision of what legacy support.
Well, I think we want to be sure that we will hopefully in the future have cases where we can even integrate the B and G in here. If you can get the B and G in here, and then you can become completely unaware of all of the VLAN tags that are going underneath, because you can just have it all managed in flow, and you could set up the B and G and the OLT and the DPU and just have it all magically happen under the covers, and nobody in the world would care. But if you're going to integrate to potentially a legacy B and G with VOLTHA, which AT&T surely has use cases where that will happen, then part of that orchestration is already happening in another way, and you need to make sure that we can match that from the legacy side and have it fit into what's already being done. So I think we should be able to do both cases and have it work either way.
What Mike, what we're saying is the item we talk about during the lockdown, right? The BNG function support on the network processor of the OLT, right?
Or some other BNG that comes under control of VOLTHA or ONOS or whatever. Could be that one, or it could be another one.
Could be on the fabric also. Okay.
Yeah, could be just anything that gets the full flow, that can be completely orchestrated and can remove that from having any knowledge of upstream systems, then that's great. But I just don't think that should be one use case we work towards. But in other use cases, we have to make sure that we can map to potentially other upstream systems that are managed independently. I guess.
Okay, great.
I think we should plan for both. That's all.
Okay. Andy, sorry for hogging your talk.
Oh, not at all. I want to make sure that any questions that are raised or things that we can address, we will flow to VLAN examples. I want to just make sure that it's understood that those would simply be examples, that it's going to be very configurable and flexible from the abstract perspective.
In terms of PON resources, what are you thinking in terms of number of key cons and number of gem ports for a given DPU deployment?
So we've seen a couple. different models. So dependent upon, Mike described at AT&T how they have some specific behaviors of aggregation of PON DPUs. We've seen 3 different patterns in our experience of how descriptive the PON QoS is, or how aware of subscriber capabilities are. Some of those go to the full extreme, where it's 100% subscriber aware, and we've seen scalability issues on certain, not scalability issues, but undesired behaviors, if I may. The other extreme is where aggregate flows, common aggregate flows that have an SLA associated with them are presented, and then the DPU chooses how to schedule things on or off of that aggregation. And the middle case is where you have something that's per class of service or per cost kind of behavior, such that you can at least have your per service types and having some aspects.
Yeah, I'm thinking in terms of, we've been having some discussions around technology profiles, and the technology profile, describes basically a TCON, a number of gems, and the scheduling policy between the gem ports themselves. So it sounds like it's kind of goes from kind of one extreme to another. So I may have a technology profile per subscriber potentially, right? So a TCON and a number of gems per subscriber, or potentially an aggregate, so a TCON and a number of gems per DPU, I guess.
Correct. And so what we'd like to do is that technological profile of how the OLT ONU behavior happens, we'd like that to be under the control. So if it is a per subscriber basis, because you have a subscriber directly off of the ONU, that would be managed via that aspect. You may or may not use a similar model when you move into an aggregation model, but you have the flexibility of doing so. But that would be completely applied to the OLT ONT via its management, not relative to a DPU, because you may aggregate an entire access node of VDSL or some historical aspect as well, right? And so we want to, our proposal is to keep that associated with the PON technology. Similar to the technology that describes that PON, there's layer 1 technology that would be applied to the DPU in a similar pattern.
I think maybe that's something we can bridge into Sean's presentation later. We did spend some time to regarding to the G.fast. My understanding, maybe there's still like something like line profile versus spectrum profile. So those there's a whether once we introduce G.fast, the profile concept getting even more complicated. So maybe I think let's hold on that discussion, and then maybe after Sean's discussion we can bring this back. Andy, hopefully you can stay on for a longer time.
There is quite a lot of extra profiles, and a lot more than line and spectrum, and there are even the needs that you can possibly have certain situations where you're going to apply maintenance profiles because a certain customer is being susceptible to a certain RFI frequency interaction. So you'll want to go put in an RFI template that will try to make him immune, and that may or may not even affect the subscriber service that he will be able to get. Or I need to need to be going and messing around on a customer by customer basis with the noise margins or a different thing. So there will definitely be things that potentially very, very complicated configurations in all of those templates that could be somewhat static, that could be assigned in a profile, but then it could be just maintenance profile after maintenance profile, tweaking this, tweaking that, tweaking the other, trying to keep the customers stable.
Error-free.
So there's a lot there in those G.fast parameters to get messed around with.
Okay, Andy, keep going.
Okay. So when we get into the technological profiles, we've been thinking about some alternatives as well, and AdTran owes this community some proposals to different thinking about that as well. So we'll continue on the current path, but we're seeing, as Mike just described, there's some low-level details that will require significant interaction, right, in an essence of time and impact, and we're thinking about ways to allow that flexibility without having to impact the state of VOLTHA itself and what it stores, et cetera. So we also owe the community a proposal from that perspective. So we'll be sharing that in the coming weeks.
I guess you're trying to address the management of the DPU portion, right?
Things that have to do with the technological, the per subscriber interface settings that are technological specific. How do we ensure that that is that VOLTHA is not burdened with trying to continue down that path of keeping up with those technological changes, and is prepared for a platform that anyone can develop a device driver, a device adapter in order to extend new technologies or new patterns without having to go and augment the core.
Right.
Are there any specific questions about the concept of two OpenFlow devices, how there's very little change to the patterns that exist inside the VOLTHA architecture today, other than Sean's request for a detailed sequence diagram to understand how that's actually realized?
And maybe later on, down the road, the zero-touch provisioning is coming up. I think you touched some of that using the EA poll and getting authenticated, right? So I think you do touch some of those. Maybe that is covered, but if there's any additional, when I say down the road, right now probably that's probably not the top highest item for the G.fast support at this point. So, but something we do want to address in the future, of discovery of DPU proposal.
Right. We had talked about that last time, not during the lockdown, but lockdown of 2.0, I believe is when it was. We talked a little bit about an external system. Again, we don't want to burden VOLTHA with that information. We wish to allow it to be a transport for some of those behaviors, but we can provide a little more details of our thoughts on that area as well. Again, we've per the request, we began investing in this area a little bit ago, and so we are marching towards these concepts and beginning to develop things in order to allow it and learn from it. And so as we continue that, you'll start to see some of that show up and what we're working on and how we're going about it.
Great. I think that's probably it. Julie, back to you.
Okay, so any other questions for Andy today? Okay, so Andy, I did hear a couple things. It looks like you're planning to contribute back as proposals for the community. So when you are approaching the point where you'd be ready to schedule in for a session on another Thursday call, please let me know so we can put you on the agenda.
Okay.
Okay. Last call for comments or questions to Andy before we switch topics. Okay, then I think we'll move on. So thank you, Andy, for that. And the next topic is a readout on the discussion that happened yesterday related to technology profiles. And Sean Missett, are you going to be presenting that, or who should I give control to? Or anyone?
Sean, are you on mute?
Yes, I am.
Okay.
Good call on that one. Yeah, so let me see if I can present this. So I just posted a copy of the meeting notes onto VOLTHA Discuss. Okay. Can people see my screen here?
Yes, we can.
So there should be just a picture of kind of the existing model of VOLTHA, the VOLTHA core, and the ONOS layer and management layer. So basically, what we did was yesterday we had a meeting that basically we took this picture and kind of just walked through the bullet points to the right of the picture. So basically, for each layer in the picture, there are a couple of bullet points around things that we may want to look at and address in terms of capabilities, and so we kind of yesterday we kind of just walked through the bullet points and talked about potential implementation issues. We didn't really get to assigning who's working on what at this point, but that's still to be done. But so the meeting notes basically just list essentially my take of what was discussed in the meeting. So basically for each of the bullet points, I brought those down into the body of this document here and listed kind of what we talked about. So basically the first points at the ONOS layer, we talked about basically adding support for the flow table ID reference to technology profile ID. So basically on a existing subscriber record, I guess it describes how what's the tagging rules for that subscriber on the UD interface, and what happens as the frame gets pushed through the OLT to the network. So basically what we're going to do is we talked about adding the flow table ID reference to that information, subscriber information, and adding meter information for upstream and downstream flows. So the status database will be updated to hold that information, and as the subscriber authenticates in the AT&T model, basically the OpenFlow management application will push down the flows to the VOLTHA core, and basically the flows are passed down to the adapters, and the adapter basically takes the OpenFlow information and takes the technology profile reference and essentially generates the technology specific configuration basically. So the idea is that we basically use the existing etcd or console database to create entries in that key value store. Each entry would represent essentially a flow table ID technology entry with essentially a blob of JSON data. I mean, that was a working model we had. So basically, the JSON formatted data would describe the technology profile as we talked about before. It describes the TCON configuration, the instance control information, the gem ports, the scheduling, etc. And so that basically is referenced with the flow data that comes down, and the adapters would use that to look up the technology profile, which is essentially a template for the service instance. And as part of our discussions, we also touched on G.fast. So there's a couple of whiteboard pictures in this document as well. So we talked about basically if you viewed the DPU as a separate OpenFlow switch, as we were kind of just discussing a few minutes ago. So basically, you could, there's two models. One is the existing model where the DPU basically is managed by an in-band VLAN management channel, and it does the call home, and basically it could be configured via, it connects to a PMA and is configured by, a netconf Yang model, or you could view it as a white box DPU, in which case we view it as an open flow switch, and we configure it the same way we would configure the OLT ONU combination, where we use open flow to configure the flows, and we can use technology profiles to reference specific TR-371 type profiles. So within the technology profile for G.fast, we'd have, the idea we'd have a vector of vectors entry, which would reference TR-371 type profile models with spectrum and line configuration data. Within the line configuration profiles are some data rate profiles, which we kind of try to extract from the technology profile itself and use OpenFlow to define those rates. So, and this is a future thing we could look at, is maybe we want to use OpenFlow meter bands to define some of those data rate profile information that might be in some of the line configuration profiles instead of having them in the profile itself. But that's something we need to investigate and look at. The one thing we're kind of a little concerned with, again, is the scalability from the G.fast perspective. AT&T indicated that so currently they use about 15 or so spectrum profiles and about 10 line profiles, and we thought just that didn't seem like overly burdensome in terms of the technology profile model. If other operators have information along those lines, we'd be happy to see that, just to get an idea of the numbers of profiles that are used out there. This just represents the whiteboard picture showing basically the first model is number one, is on the right here is just the existing model where the ONU has a in-band management, it connects to a PMA and netconf Yang provisioning, and then on the left side is a circle 2 there, which is basically the OpenFlow management model, where it uses OpenFlow to define the flows and the technology profiles to define the G.fast port information. So we talked about basically adding support. Sure.
So either Mike or Andy, depends on the different generation of the G.fast. Will there be a significant change regarding to? I'm just focused on the profile stuff right now. Will there be a significant change? Depends on which type of profile it is. I mean, or the new category.
It can, yes. Things like, well, in our first generation of the technology, we were using some DTA functionality on the coax versions of the DPU. Whereas as we move into the next generation of the technology, we will have to start using some different coordinated DTA types of functions for twisted pair. So we end up, one, in the technology, as it advances forward, different techniques are brought into line and brought into the standards. And even the interface technology that you possibly would have to use, whether it be coax or twisted pair, will have different sets of configurations, vectoring on, vectoring off, different things. So as the technology moves forward, there are definitely new features and functions that come along with it that have to get taken into account, and even new different types of profiles and stuff. So there are definitely technology differences. And also we have the coax versus Yeah. So not only from generation 1 to generation 2, but also even just between coax and twisted pair. Yes.
Okay. Yeah. So there's some work that needs to be done there in terms of the technology profiles that may be applied in those cases. We didn't really touch too much on that. The next kind of layer in the diagram was the management layer discussion point. So basically, point 3 was basically need to add support for technology profile, create, read, update, delete. And we talked about essentially using the existing access models for the XD database key value store. And we had basically decided that, we had a discussion around, being able to do an update of the profile. And we thought that was a little too complex initially. So basically we decided to support a policy. We only do create and delete of the technology profiles initially. Though, conceptually there's a way to support an update where the key value store basically issues a notification to all the all the users of a particular profile if an update occurs. But initially we thought we'll just keep it simple and just to support create and delete. So point 4 was updated OpenFlow agent to support flow table ID and technology profile reference and meter band support. So we discussed, the possibility of doing error checking, consistency checking at the OpenFlow agent level. So normally with the meter bands, you need to have created the meter before you reference it. So there's ways to validate that the meter, for any forward reference, we can validate if it references something that doesn't exist, that would be an error. The tricky part was the table ID that is used for the profile creation, which it exists in the KV store potentially, and so the OpenFlow agent could validate that a particular flow table ID exists in the KV store and generate an error, but the potential ambiguity comes from the fact that we're accessing a particular technology profile based on not only the flow table ID but the technology. So there may be an entry for flow table ID 256, 255, and for XPON, and there may be another one for 255 for EPON or G.fast. So the VOLTHA core doesn't really have knowledge of the particular technology. So we decided to keep things simple initially, that it would just validate that an entry exists for the flow table ID. If it doesn't exist, then it would generate an error. So potentially the adapters would be ultimately the ones to figure out whether there was an error or not, because they understand the technology aspect of the profile. So this was just in order to keep it simple initially, we just allow error checking based on the existence of the table ID entry in the KV store. So there was a bit of discussion around that. Next set of discussion points are around the VOLTHA core. So point 5 was that support for technology profile, database store, high availability. We said this is, if we use something like etcd, then basically that already supports HA, clusterized HA, so already exists, so that was already supported. Point 6 was adding support for technology profile access based on the flow table ID technology keys. So basically, originally we thought about adding more dimensions to the keys to the database profile entries, maybe something along the lines of a adapter type. But in order to keep things, again, to keep things simple, we decided to just use the flow table ID technology. So whether it's XPON or EPON, G.fast, or whatever the technology might be as the keys, just to, again, to keep things simple. We talked about flow decomposer support for the flow table IDs. Again, there was a bit of discussion around the architecture for how the open flow messages are pushed down. We talked about potentially not needing the flow decomposer. Sorry, it's not fitting very well on the screen here. But in the end, we came around to saying, okay, let's just keep the existing architecture as it is and have the flow decomposer essentially push down the flow messages to both the OLT and the ONU. The OLT is responsible for getting the technology profile and creating an instance of that profile. So basically, the OLT uses its own internal resource manager for TCON, GEM, port IDs, ELEC IDs, ONU IDs, and it's responsible for creating an instance of a profile. And then basically once the ONU receives both the flow information and an indication that the instance exists within the database, it can go get the instance information and basically use that information to create the OMCI messages to program the ONU. And so that this paragraph basically talks about that. And so point 8, device and adapter agent supports for updated OpenFlow message capabilities and technology profile access. The device adapter and agent need to pass all flow table ID and metadata down to the adapters. So that's just making a statement that that information needs to flow down to the adapters, the OLT adapters and ONU adapters. Point 9 was adapter access to technology profile based on flow ID derived from OpenFlow programming messages. So derived technology key based on adapter type, key value, lookup, table ID technology type to etcd. So that's basically saying that we need to create, we need to basically be able to access the flow table ID in the database based on the flow table ID and technology type. Also, when an instance is created, then we need some reference so that the ONU knows what the instance is, and we decided on basically a flow ID, which after a little bit of investigation, I think turns out to be the cookie that's associated with a given flow. I think we just need to do a little bit more investigation into the uniqueness of that, just to make sure it's unique across the different ONU and UNI interfaces for the flows that are assigned. We think it is at this point, but we just need to do a little more investigation, I think.
Not the cookie, it was the flow ID, right?
Well, the flow ID turns out to be essentially the cookie associated with the flow. I guess there is no specific flow ID value, right?
Okay.
It turns out, yeah. I mean, we just need to investigate that a little bit, make sure we have a unique handle that we can use to look up the flow. It just may be a terminology thing. Let's see. And then we talked about the points against the adapter layer. Again, the adapter converts technology profile plus the OpenFlow message data to create a subscriber service instance. We just briefly talked about that. That instance can be stored as a database entry or some other entry in the core that's accessible via the OLT and the ONU. The OLT adapter uses a resource manager to allocate available ELEC ID, GEMPORT IDs. We talked basically that in order to simplify things again in the short term, the resource management would be at the adapter level. We talked about potentially maybe bringing that as a common resource manager function that can be used across adapters. And initially we thought that just to keep things simple, the OLT adapter would just manage its own resources. We can look at that later as we move forward. Maybe it's some type B implementation, or NG.2 may move us towards some common resource manager. NG.2 may need some protocol implementation, so that different pods, different managers can communicate and share information across adapters that may not necessarily be co-located, but that's a future capability. See, point 12, OLT adapter initiates own use service creation using the technology profile and service instance data. So basically, this is the point where basically the ONU, in order to go ahead and create its OMCI messaging and configure the ONU, needs to wait for basically the technology profile instance to be there, plus the open flow message data that it receives from the flow decomposer needs to be there. So there's a little bit of state potentially needed inside the ONU to just to make sure everything's available for it to use. 13, this is just a statement that the ONU adapter generates the OMCI IME messages to create the service. 14, so this was basically the bottom-up ONU discovery authentication approach that Saurabh discussed in previous meetings. So that's basically the list of the notes that I had taken. And if there's any update to this, I'll update the document and increment the revision, and I'll post it again onto VOLTHA Core. So like I said, we just basically went through this yesterday, so I'll update if anything comes in. So basically take a read through that and let me know if there's any questions, or if you have questions now, we can talk about it. Okay, thank you.
Yeah, I think yesterday we didn't. Sorry.
Go ahead.
We didn't talk about the profile management aspect of it, but right now I think the two interfaces, CLI and REST, and you can use those to populate the profile. But I guess the management of the technology profile probably is outside the VOLTHA owners. I just apologize. I didn't send out the dialing info early enough before yesterday's call. But yesterday meeting, just a little bit update is we have ONF, we have Deutsche Telekom, we have Netsia, we have NTT on site, and the Sean from Radisys and Dave Bainbridge was also in the discussion room. I don't think I missed anybody. I just remember we have a lot of people in that room. So it's pretty good discussion. Also, face-to-face discussion always seems to be more productive than a conference call. So just a little bit update on that one. The discussion was not recorded, but Sean captured a pretty good report there. If anybody else also captured note, want to augment that, and also please provide.
Okay, thank you, Sean. Any last questions on this for today for either Sean Missett or Sean Ying? All right, I think that takes us through our agenda today, and we are about out of time also. So it's a good time to wrap up. A reminder to everyone that we are planning to kick off Sprint 1 next week. So I do know that there are stories. Sean, can you maybe go on mute? There's a lot of thank you. So we are planning to kick off Sprint 1 next week, and I do know there are user stories and epics that are still being entered. So thank you for that work that's going on in the background. And we will meet again on Tuesday to work on continued planning for 2.0 and to kick off Sprint 1. So thanks, everyone, and we will wrap up for today. I will stop the recording, and this will be posted later to YouTube as usual. Thanks, everyone.